Hi everyone, this is Mr. Nam, and today I'm going to be going over your lesson for my 7th grade science kids for Monday, September 28th. And today, guys, we are doing our final models. We're kind of wrapping up our first unit. So before you're doing that today, I want you to answer this question for me. Does container A or B show a system with more pressure? Why? And I want you to answer the question in pink below with the sentence starter. Describe how container C could have the most pressure. So I want you to think about clearly A and B have different amounts of pressure, but how can we show that C has the most pressure? Okay. That was your do. Now we're going to go over the scientists of the day. Did some breakout groups, and then you have quite a bit of independent work today. Okay, your scientist of the day today is Dr. Helen Chu. She's a Chinese American doctor. She speaks English and Mandarin. She has a medical degree from Duke University and a master's in public health from right here, UW. She is an infectious disease expert and epidemiologist at the University of Washington. And one of her projects is to study the flu. So her team had many samples from their nose already. Although the government told her not to, she began testing her samples for COVID-19. Her team's effort helped, excuse me, start our local response to the pandemic. Okay. So before we dive into your independent work, we want to make sure you understand certain terms. The first one is air pressure. That is a force on the walls of a closed container. Particles cause pressure by colliding or hitting the walls of the container. When something bounces off the walls, it is creating air pressure within that closed system. Okay. So we went into breakout groups, but today, if you're watching this, that probably means you did not come to class, so you are going to be doing this on your own. But in breakout groups, what you are going to be doing is to make models of a given state change. Okay. So what you, excuse me, this is the slide that we did in breakout groups, and what you're going to do is work on this on your own. You're going to fill in all the answers in blue. So the first thing is air pressure in a container is caused by, and you're going to write what is it caused by. Okay? And then you need to write for me 3 ways you learned that you can increase pressure in the container. So the first I give you is increasing the temperature and average kinetic energy of the particles in the container makes them move faster and often collide more often and have them collide more often and harder with the container walls. Okay. There are 2 other ways that we can make pressure higher in a container, and I want you to figure that out. Okay. So guys, the learning target for today is you're going to be able to apply information from a reading to improve your popcorn model. In a Google Classroom, I posted also a link to an article, and this is the independent work that you are going to do. Okay, so after each paragraph, you're going to stop and think to yourself, does that paragraph help me explain why popcorn pops? Put a star by a paragraph if you think it does, and underline 3 to 4 words in that paragraph that describe something you need in your model. Okay, as you can see here, the article is linked right when it loads here. Okay, so very short article should help you with the popcorn model. Okay, and this is kind of your wrapping up the unit. So your guiding question that we did was, why does popcorn pop? This is a checklist for your model of different words that should be included in your model. Okay, and your model based on your assignment is this last slide in this PowerPoint. We did this before. You started the unit with this. What's going on inside? Why does popcorn pop? You need to write your answer with the blue statement up here and also use the particle bank to show me what's happening inside the kernel. And if you have any questions, always, like always, do not hesitate. If not, good luck, and I will see you folks tomorrow, Tuesday. Bye-bye.